Good afternoon all. This is the C4 Smart Battery Charger, well, Smart Cylindrical Cell Charger from ISDT, and this has been very kindly supplied to me by Banggood.com, and I will put a link to this item on Banggood's website in the description below the video. Right, let's do a very quick unbox. And we've got stickers, we've got a screen protector which you can apply to the screen, we've got a manual, we've got the charger. Now I have been using this, so this peel off sheet I've just put back myself, so there's probably going to be a few marks on this. There's the cell bay. It's quite interesting. You put the lithium 18650s across and you put the AAs and AAAs up and down like that. Also in here there is a power supply. It's going to be 12 volts at so many amps. There's a Euro one here supply, but I'm not going to use this because I'm going to power this battery charger from lead acid batteries which are outside the room, powered by solar panels. Okay, so what do we have? Well, we have a liquid crystal display, 240 by 320 pixels. There's no controls on here other than this touch panel. It looks like 3 touch buttons, but it does actually also work as a sort of slider analogy of a rotating wheel type thing. This is IPS in-plane switching, so it's very wide viewing angles. It's a very nice, easy to read display. We've got the bay here, which takes 4 cell sizes, 18650 you can see there, 26650 also across there, AA and AAA. On the back we have well, let's start this side. We have a 2.1mm, 5.5mm DC input. Now it says on the back that it takes 12 volts at, what's that, 2.5 amps, but it actually takes up to 24 volts. And because it shows a picture of a truck, I think trucks, well, I don't know, when the alternator's running on a truck, what does it put out? 26, 28 volts? So this is almost certainly going to be able to take quite considerably more than 24 volts. Does mention the 24 volt thing in the manual, just doesn't seem to mention it on the back of the unit. Center positive that connector is. This is a fan. That's a USB output, 5 volts, 2.1 amps I believe, and there's a micro USB type B connector there which can be used to upgrade the firmware on this unit. I don't think there's anything else on the case. No, there isn't. Right, let's power it up. Absolutely appalling weather today, so I've got 12.7 volts on here. Let's connect that. A silly tune, and it shows C4 Smart Charger on the display. Let me redo the exposure so that we can see this nice and clearly. So we've got C4 Smart Charger. It shows the voltage coming in from my lead acid batteries, so it's 12.7 volts. Currently. Now there's a fading in and out settings gear wheel here, and if I press and hold, it's hard to show the markings on this touch panel, but there's a circle here, up arrow, down arrow. If I press and hold the middle control, we can go into the settings. There's lots of stuff in there. I will come back to that a bit later on. Right, I've got a compromise exposure between the display, which you can't really see, and these buttons, because I wanted to show how these can be used as buttons. So I can go through with the down button, go back up with the up button, but equally I can scroll my finger down that touch panel as a sort of sliding touch panel. So it kind of works as both. The sliding thing isn't terribly convincing. In fact, sometimes it does feel easier to just repeatedly press the up and down buttons. Okay, let's put some cells in. I'm going to put these inner loops in. These go vertically in these 4 slots. Now you can hear it beeping, and that's a sort of 3-second countdown, whereupon it goes into automatic charging. It picks the default current. It determines the type of cell that have been put in from the voltage, I presume. Let's put all 4 of these in. Now you can see that there are 4 flags, I call them here, which are indicating 63, 67, 95. These are percentages. So it's giving an estimate of the percentage charge of the cell based probably on voltage, 96%, well this one 95, 1.47 volts, that's about right for an inner loop. And we get lots of information on display, including a graph. The graphs are interesting because there's no data on the axes of the graph, so it's very difficult to know what these times are. This is presumably time running this way and voltage that way. You don't know what the voltage and the times are, but the shape of the graph does give you some useful information. This is auto cycling through the 4 cells. Each of these flags relates, of course, to each one of these cells. If you put in the 18650s acrosswise, you get the flags up here. Lots of other information: accumulated charge in milliamp hours, accumulated time, current voltage, and the current that the cell is being charged at. Now, bear in mind that as each of these flags is back illuminated in white, we're seeing the data on the display related to that cell. So when it changes to the second cell, we're seeing data for this inner loop here. Internal resistance, 47 milliohms there, and the temperature. Now, I'm not sure whether this is on a per cell basis. It appears to be, and I think I read somewhere that there are 5 thermistors inside this unit, so possibly on a per cell basis. I don't quite know how it's doing it, possibly from the temperature of these connector springs. These flags are quite interesting. They show, when they're coloured here, they show percentage charge. If I go into the menu and stop that cell from charging, or pause it, or put it in a sort of wait state, and then go back, you can see it's now changed to a grey flag, and it's saying 1.5, so it's indicating very approximately the voltage. If I go back, that cell now just sits in that waiting state. If I scroll through the 4 cells, it then wants me to set this one up. It's beeping because it's in auto. Actually, I didn't quite catch it in time, so it has gone into auto charge. Let's go across to that cell. Incidentally, when you switch between the cells, up and down don't do up and down. In fact, this whole touch panel just cycles from left to right. You can't go up and down, it just cycles through. These 2 cells are very near finished. 1.53 volts on that one. On this one, 1.51 volts. Right, the fan has come on because it's charging each of these 4 cells at 1 amp. So that's a total of 4 amps that the unit is putting out. The fan doesn't seem to come on that much with the lower voltage cells. It does seem to come on a lot more with the lithium cells. Obviously, I suppose you've got a higher voltage multiplied by the current. That's more watts. It is a very small fan, so inevitably it's quite noisy. If you wind the charge current down for the cells, you can get it to come on less often. Oh, it's gone off. But yes, that is quite a noisy fan. End of charge detection for nickel metal hydride does seem to be really quite good. If I switch to cell 3, which looks like it's quite close to reaching end of charge, you can see that the top has completely flattened off. When that starts to drop down, this thing quite reliably detects end of charge. Now, is that cell warming up? Yes, that is slightly warm, certainly warmer than these 2 cells over here. So I'm expecting this 3rd cell to complete charging fairly soon now. Right, let's switch to lithium cells. The display's just gone off, but I can bring that back on just by hitting that. And this is where I've got a bit of a gripe with this battery charger, because although 18650s will fit in here, anything longer, like these protected 18650s, which are of course longer, they're about 70 millimeters long, they simply don't fit. You cannot make that fit in there. Let me just change the exposure so we can see that. Yes, that simply doesn't fit within the aperture of this plastic receptacle, and there are flush sides in here, so even cutting this away wouldn't help. So this battery charger simply will not charge protected 18650s or 18650s with the little hole on the little socket where you can charge them from USB. It can only charge unprotected cells. Okay, let's put these in. Now, the first one I'm going to deliberately put in reverse polarity. Positive is actually on the right, and that's just so that I can show that the unit has reverse polarity detect, and so it's quite happy if you put them in the wrong way around. Not quite sure what happens if you put one in the wrong way around and one in the right way around. I'm not entirely sure. I want to try that out. Okay, let's put this in the correct way around. That's beeping because it's going to go into an auto charge. It said 1.5 amps there. I'll reset the exposure in a moment when I've put both of these in. There's the second one. Again, it's in auto start, auto charge, and away it goes. Let's get a bit closer in and take a look at the display. Right, with 18650s in there, the fans come on immediately. I don't think that's going to go off because, of course, we've got much more voltage here and a reasonably substantial current. That's dropping away, so this must have hit, 4.2 volts. This must have hit the constant voltage phase. This cell is this top one is much less well charged, 3.63. That's charging at 1.5 amps. 1.5 amps is the default for lithium-ion 18650s when doing a charge. One of these seems to be very uncharged and one seems to be much more charged. We've also got indicators here for internal resistance, 137 milliohms on the top cell, and in a few seconds it will switch to the bottom cell, 122 milliohms for that bottom cell. That's now hit 4.2 volts and is in constant voltage charge mode. Notice that when charging lithium ions, which sit across the charger, these little indicator flags sit on the left hand side here. The top one, of course, relates to the top cell. If I go into the menu, I have to press and hold for that and go back, thus pausing that one. You can see that it shows an approximate voltage for this top cell, 3.6 volts. Let's actually pause the other one. And of course the fan turns off because there's no power dissipation. That one is approximately 4.2 volts. So this is kind of in a wait state. Right, one of these cells I just restarted and it's immediately said that charge is done. It's at 4.21 volts. Let's switch to the other one. That goes into the auto countdown for automatic charging. That one, of course, isn't charged, so it ramps up to 1.5 amps. That's only at 3.62 volts. Let's have a look at the one that's done. We've got no graph information because it was done immediately that I restarted the charging. That's a shame, but there will be graph information for this other cell, which currently says it's at 9% state of charge. Just wait for it to switch to that one. Yes, if you intercept the auto switching between pages of information for the cells, it actually sits there for quite a while before it goes back to the auto switching back and forth between the two cells. And it's just done that. 3.64 volts. The USB output on the back here, this type A socket, is smart in the sense that if it's providing 2.1 amps to your phone, it will actually knock the current to the cells down a bit. So in a sense, it gives priority to USB charging and not priority to charging of the cells. Not sure quite how useful that smartness is. Right, let's put in this fully charged lithium cell and see what happens. If you don't want it to automatically charge when you put the cell in, you can either intercept by pressing this touch panel so that you can now make changes to the settings, or of course you can go into the settings and change the default setting for auto charge, which is there. Let's go up to that. You've got the options of 3 seconds off or 5 seconds. So if we leave that off, it won't auto charge. Let's go back to off and back. It won't auto charge this cell when I put it in. It will simply go to this screen and I have to make the settings myself. Now it can auto detect the chemistry type, or you can go in and set it to lithium ion phosphate, lithium high voltage, nickel metal hydride, nickel cadmium. Those are grayed out because it can see that the cell is at 4.2 volts. Nickel zinc eneloop, which is singled out separately from nickel metal hydride. I'll come back to that later. But I'll use the auto setting there. We can also either charge the cell or we can discharge it, set it to a storage charge, cycle it, do an analysis on it, or do an activation charge. Let's just go back to charge. And of course, current, we can set from a range of currents. I'll use this in scroll wheel mode. Actually, I won't use it in scroll wheel mode. That goes up to 3 amps maximum current per slot. and it goes down to a minimum of 100 milliamps current per slot. But let's put that back to where it was initially, which is 1 amp, and start the charge. Let's take a look at what it does with a fully charged lithium cell. And you can see that it's fully charged because it's immediately hit 4.2 volts at 1 amp. Right, so what's happening now is it's holding at 4.2 volts, 4.21. The current is dropping fairly rapidly. So this is in the constant voltage phase. The voltage is being held constant. The current is being dropped. That should terminate really when it gets to nominally a tenth. Oh, well, there it is. It has terminated. It said that the cell is full, so the constant voltage phase didn't last very long on this fully charged cell, and of course that's what you'd expect. Okay, let's see what happens with a fully charged inner loop. Now again, I've got battery auto, so it's going to make an assessment based on this voltage here of 1.5 volts. Probably going to choose nickel metal hydride. I can charge, discharge, all the other functions, and I can also, I didn't mean to do that, I can also change the current, but 1 amp seems fine to me. So let's come down to start and set that running. Let's see what it does with an inner loop which is fully charged. So it's pushing the voltage ever higher, currently at 1.52 volts. It's holding 1 amp because it doesn't really matter what voltage nickel metal hydride goes to by putting in current or charge beyond the fully charged state of the cell. All that happens is that the extra energy is turned into heat and dissipated as heat. That doesn't necessarily damage the cell, so it's not dropping the current. There's no constant voltage phase for nickel metal hydride. What it's looking for now is a topping out of the voltage, a little dip, and then it should terminate. Let's see if we see that. So it looks to me like this graph screen fills up when you get to about 2.5 minutes of graph data. Then what happens is the thing just continually rescales. So you'll see that it just rescales itself continuously, and it always shows a full graph. As I said, there's no time information here, no voltage information. You have to infer that from other data on the screen. I mean, on a lithium, for example, you would infer that the flat top would be at 4.2 volts. You can't really do that with nickel metal hydride. Right, so the graph is showing a relatively flat top. There's a few wiggles in it. It looks like it's just starting to dip down a bit, so it might be close to the point where the delta V algorithm will detect that it is at the end of charge. It is starting to warm up a little bit. It's not really detecting that on the thermistor because it's going to take a while for heat within the cell to run out to whichever contact has the thermistor on it. That's just gone up a bit actually to 30 degrees C. We've got another drop in voltage. It must be very close to end of charge, termination of charge. It's almost worth me sitting here and babbling on until that actually happens. And there it is. It's gone to the green tick. It's seen enough decline in voltage to determine that that is actually the point at which the cell is fully charged, and it's terminated the charge. Now, in terms of battery sizes, the manual interestingly says you can do 10 440s, 10 500s, 12 500s. In other words, non-650 length batteries. So would that be that you would be putting lithium cells, let's just turn the display back on, into actually the AA or the AAA bays? I would imagine the circuitry is such that it can detect different chemistries in all of the various bays. That would certainly seem to imply that. Here's the list of chemistries. Now, what about this business of singling inner loop out as a different chemistry from nickel metal hydride? Of course, it isn't a different chemistry. Let's have a quick look at that. If I put this inner loop in, this is now fully charged. It's quite warm. So I've switched off the auto charge, so it's not going to do an auto charge. Let's go into battery types, and I can either choose nickel metal hydride or I can choose inner loop. So let's choose inner loop. And you can see from that the only thing that changes is that it's going to charge it at 1.5 amps. If I set that to nickel metal hydride, it's going to charge it at 1 amp. It can't detect that there's an N loop in there, but it does just seem to have this other setting. So if you manually choose N loop, you'll get a 1.5 amp charge rather than a 1 amp charge. Let's go for a 1 amp charge. I feel that 1.5 amps is slightly aggressive. So in summary, yes, this is a very interesting battery charger. I like the small form factor. I particularly like the ability to take a wide range of input voltage. The bay here is flexible in that it can take lots of different battery sizes, but unfortunately for me, really let down by the fact that you can't fit over length lithium 18650s, which are more like 18, well, I suppose it would be 70 millimeters or more in length. They simply do not fit into this charger. That's a real shame, because most of my everyday use lithiums are the protected type, because I tend to use them in flashlights. I like the fact that you can set the current per cell from anything from 100 milliamps right up to 3 amps. I think the charger itself can provide a total of 8 amps to however many cells are fitted into the unit. The LCD is extremely bright, very readable. Most of ISDT's products use this 240 by 320 IPS LCD, so it's got very good viewing angles. The colors are fantastic, and I do like all this information, not just voltage, but a whole mass of other stuff. The internal resistance measurement does seem particularly good. The graphs are very useful, but they're not, you've got no actual numerical data on the graphs, but the shape of the curve does give you some interesting information about how the algorithms inside this unit are actually charging and discharging the cells. I like the reverse polarity thing. I'm often absent-minded enough to put 2 cells in back to front. Let's actually give it a try with one way and one the other. Yeah, it seems happy with that. I don't think I've blown it up. So that's a really good feature. So the only downsides I can see are the slightly noisy fan and this. It won't take over length 18650s. Cheerio.